let's look at an example involving equilibrium. So static equilibrium is where all the forces are in balance. This example is similar to the one that you might see in the conceptual physics packet that you might get from your professor. So here is a situation where we've got a block on a table. It is connected to another block that is tied to it, and the string is hanging over this pulley. Now all the pulley does is change the direction of the tension force that is there pulling with this string. So what is that? Well, to find it, first let's come up with some numbers. Let's call the large block here on the table, let's say that that is a 1,500 Newton block. And that the crate down here, let's call that a 500 Newton block. Now we have everything that we need. We'll say that this system of the two blocks is at rest, meaning that the system is not going to accelerate or change its state of motion. This block has a weight, and that weight is equal to 500 newtons. Well, that means that there's a tension force that must be pulling up on it that is equal to 500 newtons. And we'll call that the tension force here. How do we know that it's 500 newtons? Well, the net force here is equal to 0. And we know it's equal to 0 because there's no change in the state of motion. It is not accelerating. So, if there's tension force pulling up with the string this way, that means that the tension in the string pulling this way is also 500 newtons, because the tension in the string is the same all along the string. So tension here is also 500 newtons. Now we have a weight for this block right here, and we said before that that is 1,500 newtons. Now in order for this to maintain a state of rest where there's no acceleration, we have to have the table pushing up on this block with a force equal to the weight that's pulling down. So I'll make sure that I mark this weight right here. And I'm going to draw an arrow that is equal in size, but pointing up, and this is going to be the normal force, and that's going to be equal to 1,500 newtons. That's what the table has to push back up with. And then finally, in order for the tension that's pulling this block to the right on the table, in order for that to be balanced, we need to have a force that is, well, holding the block back, so pulling or pushing to the left. The only force that makes sense here is going to be friction between the table and the block. So I'm going to draw an arrow that is pointing that way, about the same size as our tension arrow, so I'll just draw that right here as if it were a free body diagram. And this force is going to be friction. So the frictional force has to equal the tension force, which is pulling to the right, and that frictional force is equal to 500 newtons. So that is our analysis of this two-block system where one block is hanging off of this pulley.